There's another selection method that I want to talk about. It's really cool. It's called Select Similar. Everything in this file is exactly the same, so I want to open up a different file for you. Let's open up the mechanical example-imperial.dwg file for this chapter. Browse to it and open it up. This is just a simple flywheel. It's a 2D drawing and it has 3 different orthogonal views in it. Here's the front of it. You can see the shaft opening with the key, some notches, some mounting holes, etc. Here is a cross-sectional view of that from the side and one of the top. Now, you can see here in our selection, because we have our selection cycling on, that there are more than one objects here. Part of that's because I'm hovering right over these 2 lines, this line and this line. So I can pick it and it tells me line, line, they're both blue. Sometimes it's hard to tell which one it is, but as you move over in your selection cycling, AutoCAD will highlight the line or the object that you want to pick. And if neither of these are correct, you select none and it won't pick anything. So selection cycling can be very useful. But let's say I want to change all of these little circles here. I can go through one at a time, picking the ones I want. Or, since they're all the same in my file, I can select it and then right-click and use the Select Similar option. Now it picked all of the circles that are on my object layer. That includes this big one. Well, I don't want to change that, so I'm going to remove it. I held the Shift key down and selected the circle. So that was much easier than going through and picking each one of these using any of my methods that I want. And while you go and select your objects, you can use your scroll wheel in the middle of your mouse to pan around. See, that was a lot more difficult. But once I do that, I can start the erase command and erase all of them, or move them or copy them, whatever I would like to do. I can also select this center line that's a circle, right-click, and select Similar. And as you see here, there are no other circles on that layer. But if I pick this line here, select Similar, there are quite a few lines on the center layer. Now you can change the Select Similar criteria. It takes a couple of steps to get to it, but you have to type in the command Select Similar, and now you type in SE for settings. Press Enter. Now you're going to select objects based on these criteria. You can pick any of these, and typically this is what you're going to want. Name is the type of object. So when we picked these little circles, it was looking for an object called circle. Well, that's all of these here. That's this big one. That's the center line here. Those are all circle objects. But the other criteria was layer. So it looked for all of the circles on the same layer that the one is that you originally picked. So that's very useful. You can pick line type scale, line weight, plot style, object style, or color. You can add that to these. But typically layer and name are the ones you're going to want. And these are the default settings. But if you just want to pick everything that's on one layer, you can turn name off, click OK, and select an object, press Enter. Everything that's on that layer has been picked. And that's a great way to clean up a layer. Remember though, AutoCAD is going to keep the criteria however it was you used it last. So make sure that if you do something special, it's a one-time thing, you might want to make the effort to go back and put it the way it needs to be. And there you go. AutoCAD gives you several different ways to select objects. Remember some of those whenever you go to Start. You have your crossing window and your selection window. You'll use those most often. Plus, you can pick an object one at a time. You have the fence command. You have the Select Similar. You also have your window polygon, the WP, or the crossing window polygon, which is CP. And you have your Shift key, which you can use to unselect things. This will save you a lot of time and effort through your drawing process. There are many ways to work within AutoCAD. There is the ribbon and the command line, to name a few. These are two of the most important and most often used input methods in the user interface. The ribbon is very straightforward. Go to a tab, go to a panel, then click the icon you want to use. And that starts the command. Very simple. The command line, though, is a bit more involved. In fact, no matter if you use the ribbon, toolbars, menus, or whatever, you still have to use the keyboard for input. There are some tricks that you can use to be more efficient with it, though. In other sections, we spoke about entering commands on the command line, like the line or the arc commands. We also discussed command aliases for those commands. For example, the command alias for the line command is the letter L. Just type in L and press enter. And you've drawn a line. A for arc. And you've drawn an arc. Quite simple. But what if you type the wrong thing? It's okay, it happens. We all do it. You can work in the command line as if it were a single line text editor in a word processor. I can come to the command line, click inside it, and start working. So if you make a mistake similar to this, you can use your arrow keys to move the cursor around. You can backspace or delete to get rid of text you don't want. You can even use the home and end keys to move to the front of the line or to the back, just like in a word processor. Remember too that pressing the up and down arrow keys will navigate you through the menus, or if you're not in a command, pressing up or down will toggle you through your most recent commands. So there are a lot of ways to use the command line and dynamic input to use or start or activate commands. When you execute a command, there are usually some sort of instructions or a request given to you by Autocad. It will need more information. The circle command is a fantastic example. You would think that a circle is a very simple thing. It's round, it has a center point. Well, there are a lot of different ways to draw a circle in Autocad. By default, when you start the circle command, you pick your center point and you enter in the radius of the circle. You can just pick a point or you can type in a set distance. Well, what if you want to enter in the diameter? Well, you can take that diameter, do the math, divide it in half, and there's your radius. Or you can start your circle command and follow the command prompts in your command line. Now, you can click on the word diameter, and now you're drawing your diameter. Or you can just type in the letter D for diameter. So if I start my circle command, type in the letter D, press enter, I'm now drawing with my diameter. That's very basic, but let's start the circle command again. It already starts off before I've done anything. Before I've picked the center of my circle, I have options. I have 3 of them. I have 3P, 2P, and TTR, which is tan radius. This will allow you to draw a circle in a different way. Maybe you don't know where the center of your circle needs to be. For example, let's look here at this little widget. Let's say we want to draw a circle. It comes from this endpoint to this endpoint. Well, where's the circle center? What's the radius? What's the diameter? I don't know. I can pick the 2P option, and this will draw your circle based on 2 points. It picks your first point there, and then as you move the cursor around, it draws a chord in your circle. That will define where your circle goes. Pretty cool. I can also use the 3P method. And again, I can come down to the command line and pick it, or I can just type in 3P. I pick my first point. I pick a second point. That defines 2 points on my circle, and now my third point. There are a lot of ways and a lot of reasons to draw this way. Now, similarly, the tan radius will ask me for a tangent of the circle, we'll say this line, to another tangent for the circle, this line, and now it will ask me for a radius, let's say 5 units. So it drew this circle tangent to these two lines with a radius of 5 units. If I extend these lines to my circle, you'll see that they're tangent to them. And if I trim it, I have a nice tangential arc to the end of my widget. So there are a lot of different reasons why you would want to draw a circle in different ways. It's going to be based on the information you already have and with what you want to do. Now, if we knew what the radius of this circle was going to be, or if we knew where the center point is, then it would be very easy to use the default circle commands. So look at your command line when you start a command and see what it says. It will typically show you that you have more options available, but not always. Entering a command can be tricky from time to time because you have so many options. When you put something on the command line, then you can use different things. Typically though, you'll be able to just enter in your command. Type it in, just start typing wherever you're at. And when you're done, press enter. That starts the command. Another option besides the enter key is the space bar. The space bar in AutoCAD, unless you're typing in text, functions just like the enter key. So when I'm starting a command, I can press space and that's enter. I can start my command, pick a point, do things, and press the space bar. The space bar and the enter key in AutoCAD are the same thing. That's nice because the space bar is much larger and it's much easier to hit with my left or my right hand while I'm working. And if you have your mouse set up, your right click functions as the enter key. Remember, when you're not in any commands, and if you hit enter, that will restart your last command. So I can draw a line just by pressing enter. I can restart the line command again by pressing enter again, or the space bar. Now to cancel a command, you just press the escape key. That cancels out what you're doing and nothing happened. But be careful because there is the dreaded F1 button. Hitting that will open up your help window. As you go and use AutoCAD, you're going to learn that you want to hit the escape key but often miss and you hit the F1 button. It's going to happen. If it hasn't happened to you already, it will happen, trust me. Many users have literally ripped off the F1 button so they don't hit it by accident. And yes, it does happen that much. You can also type in a question mark. Press enter, and that will open up your help window as well. So removing your F1 button won't hinder you, unless of course you need it in some other program. AutoCAD is fully equipped with an undo feature, which is one of my favorite options or commands in AutoCAD. To get to it, just type in the letter U, or just type in the whole word undo. If I type in U, it will undo my last command. I can also press Ctrl Z. That will undo something. Or I can come up to my quick access toolbar and click the undo arrow. This arrow here will give me a list of a lot of the commands I've already done. As I move the mouse up and down, you'll see they're highlighted in blue. All of these are going to be undone if I pick this last circle here. Boom, it undoes all of that stuff. And then you have a redo option. Redo doesn't work so well. We'll talk about these a little bit more in depth. It'll really only redo your last thing. Now, if you type in the word undo, you're going to get a lot of different options, just like with the circle. Each one of these things does something different. And you can tell AutoCAD to undo the last 4 things I've done, and it will. You can also mark a point in time and say, I want you to go all the way back to that point. That's very handy if you're trying out a new concept design. And you say, hey, let's mark this point, and try out this concept. Say, oh, it didn't work, go back. And it goes back and undoes all of that stuff you tried. That's very cool. It will reset you to where you were before. One other thing in our advanced operation techniques here that I want to go over is the need to start a command from within a command. Not everything can do that. You can't start the line command while you're in a circle command. Obviously, that would be silly. But there are some things that you're going to want to do, like pan and zoom. These are called transparent commands. The most common of these are going to be your pan or zoom commands. There will be times when you need to zoom in really close and draw a line from something like this circle, and then draw another line from it but then you will need to pan out or zoom out to draw the second part of your line. Now, when you start a transparent command from the ribbon, it's automatic, and you don't have to do anything special. For example, let's draw our line from the circle, and we go to the ribbon, the View tab, and Pan. Now this will allow us to pan over to where we need to go, and hit the Escape key, and now I can draw this line to the center of my circle. And there you go. You can also use the scroll wheel. Zoom in and out, or pan back and forth transparently within a command. So I can zoom in, zoom out, pan, zoom back in. These are transparent commands. And ever since the scroll wheel became used in Autocad to zoom in and to pan around, I haven't really used transparent commands and thought about it in a long time. But if you're entering in your commands on the command line, so if I'm starting off a line, snap to the center of the circle, and I want to enter in the zoom command, I have to use an apostrophe. Type in apostrophe and then Z. That will give me a real-time zoom. So I can type in my window zoom, and it will zoom me in, and now I'm back to drawing. Well, again, honestly, I don't do that too much anymore because the scroll wheel does it for me. But if you need to, I wanted you to know about it. Again, you may never need to, but if you do and you want to enter in everything that way, because let's say you only have a 2-button mouse or the scroll wheel isn't working for whatever reason, and you still need to work, and starting your command, then going to the View tab on the ribbon, picking Pan or picking Zoom, can be difficult. It takes more steps. You don't want to use more steps. You just want to work. So apostrophe Z or apostrophe P for your transparent commands. When you make a drawing, it is designed in some sort of linear measurement. Most of the world uses the metric system, while other places like the United States use the imperial system of feet and inches. AutoCAD doesn't really know what those units are. It only sees generic units. Drawing units are relative to AutoCAD. It will only interpret the units when you go to print your drawing or when inserting other AutoCAD files or blocks. It will translate your drawing's units to fit the way you want to look on paper. AutoCAD will take your line work and apply it to a scale factor when it prints. It will take the size of the paper you are printing on and scale your drawing objects accordingly. When you draw, make sure to know what units you are using. Your units can be anything. In fact, they can be feet, or they can be inches, they can be meters, kilometers, or even parsecs. It doesn't matter. What does matter is that you draw to full scale or to real scale, and you only draw in one unit. There is a units setting in AutoCAD where you can define or at least declare what your drawing units will be. To do it, just type in units on your command line. This will bring up your drawing units window. Here you will designate the type of units that blocks will be inserted in, or other drawings. It also sets up the way your units will be displayed while working in AutoCAD. You can choose from your length or your angle settings, and then your insertion scale. The insertion scale is where you declare, essentially, the type of units you are using. In this case, this drawing is drawing in inches. If you pick on the box, you can see all of the different objects you have. You can make it unitless, which I suggest you never ever do. It will just confuse AutoCAD and you, especially when you go to print or to insert other AutoCAD files. Pick something. Commit to it. So this file is set to inches. You can also draw them as feet, miles, millimeters, centimeters, meters, kilometers, micro inches, mils, yards, angstroms, nanometers, microns, decimeters, decameters, hectometers, gigameters, an astronomical unit, which is the distance from the Earth to the Sun, light years, or even parsecs. I think all I've ever done is inches, feet, millimeters, to be quite honest. It will depend on your design genre and what you're drawing and how you need it drawn. This shows you how everything will be outputted, or how it's going to look when you draw. It's simple enough and fairly straightforward. Now, your length type is up here. This will define several different things. You can choose from engineering, scientific, architectural, fractional, or even decimal. Each one works a little bit differently. The architectural and engineering display notations assuming that you are working in inches, and it will display your units in feet and inches. When you draw with either of these settings, an object of a unit length of 1 will be 1 inch long. A length of 12 units will be 12 inches long. Yeah, 12 inches is the same as 1 foot, but AutoCAD will only see it as being 12 inches. It is smart enough, though, and can interpret 12 inches to be 1 foot, and will display it as such. It will display it as 1 foot dash 0 inches long. Architectural format will display fractions of an inch in fractional form, while the engineering setting displays them as decimals of an inch. So in architectural format, if I draw a line, pick a point, and I tell it to go 12 or 1, it will say 1 unit that direction. That object is 1 unit long. Now I can lengthen it, and to make it over 12 units, as you can see, AutoCAD is smart enough, it tells me it's 1 foot 9 13/16 of an inch long. That's how long it is. I can change this display setting. I can switch from architectural to decimal. So now when I select the object and see how big it is, it tells me that it's 21.82372 units long, which is 1 foot 9 inches, etc. So depending on how you want to work, on what you're doing, if you need to work with inches and you need decimals, maybe you're working in a machine environment and you're going to be machining surfaces, that may be what you want to do. But if you're working as an architect, you're definitely going to want to use the architectural settings. Typically, a civil engineer will work in the decimals. And typically, if you're working with metric, you're going to want the decimal setting. Now, switching from one unit type or insertion scale to another won't change your line work. It won't automatically interpret this drawing as from going from inches to millimeters. As you can see, it's going to give you an error message. This is still the same length. But when I go to insert a block or to insert another CAD file from someone else, it will just see the units as being metric and will automatically scale that object for me. So you need to make sure that's correct, or else it will scale it and interpret it incorrectly. So that's what you need to do here, is to make sure this is set properly. You also have angle settings. They are the decimal degrees, which we'll use most often, degrees, minutes, second, which if you're a surveyor, you might want to do that, but they have survey units, which is very unique to a surveyor. You have gradians and radians. Typically, you're going to use either the decimal degrees or the degrees, minutes, seconds. Survey units look a little bit different. They go with northing and easting units. Now you have your precision settings. This is how precise that AutoCAD will display the length of your objects. You can go to a 1/2 inch, 1/4 inch, 1/8 of an inch, all the way down to 1/256 of an inch, if you're in architectural form. If you go to decimals, it's how many decimal places past the decimal that it's going to be. Otherwise, it will just round up to any of these units. So be careful. Depending on what you need to do and how you need to do it is where you need to set your precision to. The angles are the same way. I can go to as many degrees, minutes, seconds that I need to. One of the problems with AutoCAD is that it can be so extremely precise. You can draw much more precisely typically than what you can ever build. So keep that in mind. And just because that you can draw something in AutoCAD, it doesn't mean that you can build it that way. Working within a certain set of defined units is crucial in AutoCAD. You can only work with one set of units at a time. So how do you do it? Well, first you have to define your units. This is where a template file comes in very handy. You can have this already set up for you. Just start with a template. You can set up multiple templates, one set up for inches, one set up for millimeters, etc. But if your template isn't set, which it probably isn't right now, then you need to set it up in your own file. And that's easy to do. We looked at that in the last section. Just on AutoCAD, if you want to make a new file, and then type in the word units. You can also go up to the application menu, go down to Drawing Utilities, and go to the Units option. Click it. And set up your units here accordingly. For this example, we're going to use decimals and feet. This means that one unit will be 1 foot long. So we want to set up to decimal, and we want to set the insertion scale to feet. This doesn't change your units in AutoCAD, but it will affect how other AutoCAD files or blocks are scaled when you bring them in. So you can draw in feet in this drawing here. Then you can get another drawing that's made by someone else that's drawn in millimeters. And as long as your insertion scale and their insertion scale are set up correctly, it will take the other file and scale it accordingly so that it is in the actual size that it should be. Okay, in this example, we're going to assume everything is in 1 foot, since we're in feet and we have decimals. That means when I draw a line of 1 unit long, it will be 1 foot long. It's good CAD practice to draw everything to its real length. That means that if you need to draw a room that is 15 feet wide by 20 feet long, then you draw it 15 feet long by 20 foot wide. Don't scale it, don't guess at it, draw it exactly that. This is good for several reasons. 1, you are always creating an accurate drawing. And 2, your drawing will be properly drawn to scale when printing. And 3, others that need to use your file will know what's going on with your line work. Typically, AutoCAD users will work with one set of drawing units, whatever they might be. Sometimes, though, you will need to work with files that are drawn in different units. That's why it's so important to define your units in the Unit Manager. If this is done properly, then AutoCAD can interpret the different units accordingly and scale the line work as needed when you bring it into your drawing. Keep in mind that not all CAD users are created equal, and none of them are as responsible as you are. And they may not have properly set their units. So it's a good idea to check the file before you work with it. Let me give you an example. I'm going to close this file. In this file, this is an architectural example drawn in inches. So if we check the units, we'll see that it's in inches and it's set to architectural. If we use the distance command by typing in DI, we can measure the sizes of the rooms, the walls, etc. So this room is 12 feet by 26.5 feet. Overall, this building is 64 feet by 40 feet. So we get an idea. I have another file open called the Civil Example, and this is in Imperial. Its units are in feet and decimals. It's just a small road and another road, a little pond, and then 3 lots. This outline or building footprint, it measures 40 feet by 70 feet. Now, if I want to take that building that I showed you and I want to insert it into this drawing, it's very simple to do. I type in the Insert command. And then I can insert any of these blocks that are already in here, or I can browse to a folder. You can browse to anywhere that you have access to. And I want to insert the architectural example file. So browse to where you have this, select it, click Open. Now we're going to insert it by scale. Now, since both drawings were set up correctly, our civil example is set up in decimals and feet, and the architectural example is set up in architectural units with inches. AutoCAD, as you can see here in the block unit, is automatically scaling this accordingly. So both of them have units. One unit in the civil drawing is 1 foot. One unit in the architectural drawing is 1 inch. So I'm going to click OK, and I'm going to tell it to put it right here. And now we can move this around however we want and however we need. And we've inserted our building to scale here. So we can measure this with the distance command. We can come to this endpoint and measure it across. We see that it's 40 units. 40 units in this drawing means 40 feet. Now, if we go back to double check, and you can toggle back and forth through drawings that you have open by pressing Control and Tab at the same time. DI, again, for distance. Pick this point, and then pick this point. Both are 40 feet long. So that's fantastic. That worked exactly the way we wanted it to. Now, I'm going to undo all of this. We undid everything. Now let's check the units again. We're still at feet, but I want to change it to inches, which is going to be wrong. Okay, and now let's insert that file. Browse to it. Remember, typed in the word insert, I-N-S-E-R-T. Browse to the file you want. This is it. Click Open. And you can see the unit is set to inches, and the scale factor is 1. So it's going to bring it in at 1 to 1. And now what happens? Our building is as big as our whole entire subdivision. That's because AutoCAD thinks that the units are the same. It thinks that they're both inches. So 1 inch is 1 inch. Well, 1 inch equals 1/12 of a foot. So this is 12 times too big. So it will measure the same units across, but it thinks it's in inches. So it was 40 units long, but it scaled it to inches times 12 because that's the scale factor. So it makes it 480 units long. So getting your units correct can help you, and it can help you save a lot of time and a lot of effort, and it makes things more accurate. So just take the time to set your units to whatever units you're using. And when you get another file, take a few moments to make sure it's set correctly. If you forget to do that and something comes in too big or too small, then check your units in your file and in the other. How does AutoCAD know where your objects are? Well, it uses a Cartesian coordinate system known as the User Coordinate System, or the UCS. When you turn AutoCAD on and opened up a drawing, you might have noticed the 2 arrows that appear at the bottom left portion of your screen, down here. That is the UCS icon. It's there to help you keep track of your coordinate system. Now this is where AutoCAD and AutoCAD LT are slightly different. What I'm doing here now in this example has been done in AutoCAD. So I want to show you in both ways, the way AutoCAD and the way AutoCAD LT handles it. The X and Y axes are the same in AutoCAD as in AutoCAD LT. Where they differ is in the third axis, and we'll talk about that in a little bit. But if you have ever plotted points on an X and Y graph or chart in math class or somewhere, then you're familiar with a coordinate system. AutoCAD's UCS, again the User Coordinate System, is a fairly typical coordinate system. The numbers in the X direction on the X axis are the horizontal axis, left and right of your screen. The Y coordinates, right here the Y, are for your vertical coordinates. So X is horizontal, Y is vertical. Vertical meaning straight up and down on your screen. There is a third axis, that's the Z axis. That's where that little square comes. It comes and sticks right out at you, comes right out of your screen. Now this axis isn't really accessible in AutoCAD LT, but if you're using AutoCAD LT and you open up a drawing that was made in regular AutoCAD and that file has objects that are drawn in it, they're there. It's just going to be a little tricky to access them, so just be careful. The three axes together create a 3D grid. In AutoCAD LT, there's just a 2D grid. And we use these to draw in. As you rotate your grid like this, and you can only do this in AutoCAD. If you're doing AutoCAD LT, you're only going to be able to rotate in your X and Y axes. You can kind of get a better picture of what all three axes look like. I rotated the screen by pressing the Shift key down, holding it, and then pressing and holding the middle mouse button. This performs a 3D orbit in AutoCAD, but not in AutoCAD LT. So you can kind of see what it looks like. And you can reposition your user coordinate system in a lot of different ways. And that will help you to draw different objects. So if I want to draw a rectangle, I can. It's still drawing in the X and Y plane. And as you can see, it's flat. We'll talk about different things like that a little bit later on. But to return, just type in the word plan and click on world. And that will reset you to the regular XY plane. Now each coordinate along an axis is 1 unit long. As you move your mouse back and forth, you can see in the bottom left-hand corner my coordinates. And these are your drawing coordinates. Now you can turn those off and on by pressing Control and I. So as I move around, it tells me what coordinates I'm in. That's pretty handy. So it gives you an idea of where you are and what you need to know. You can also learn a few things about the sizes of things. I can see my coordinates here and do some quick math, and that'll let me know that this is about a unit long. So the coordinates can be used a lot of different ways. The number on the left, as with most standard Cartesian coordinate systems, is the value of the point on the x-axis, or the horizontal axis in this case. The number in the center is of the y-axis, or the vertical axis here. And then the third value is the z-axis. As you can see, as I move around this plane, and in AutoCAD LT, it's at 0. So let's draw some lines and find their coordinates. So just start in a blank file and draw a line. Type in L for line, and then pick a point anywhere. And then draw it to somewhere else and press enter. So we want to find the coordinates for the endpoints of the line. Select the line, and these blue boxes that are on either the endpoints and one on the midpoint of the line are called grips. I'll show you how to use grips to edit and to work in AutoCAD later on. But right now, you're going to just put your mouse right on it. And as you see in the bottom left-hand corner, those are the coordinates for that point. So you can write that down. And then as you move your mouse, the coordinates change. And if you hover over that other grip, you get the coordinates for that point. And you can do the same thing with this box. You can get your coordinates and then you can plot it out on a graph, or you can use those for points to locate something else. As you move left or down the screen, the values of the coordinates decrease. As you move up or to the right, the values become larger. Well, every coordinate system has an origin, and it's typically found at the coordinates of 0, 0. Well, that's the same case here. We're at 0, 0. AutoCAD works the same way. So that also means that you can have negative coordinates in AutoCAD. And in math, the positive and negative values often indicate direction. So a positive direction in a line or in a coordinate means it's moving to the right or up. Negative is going left or down. It's the same sort of thing. When I move over here to the left and lower of the UCS icon, you can see my coordinates are negative. To the top right, they're positive. And the X and Y become positive and negative accordingly. You can draw objects to distances, or you can draw them to static coordinate points. For example, let's draw a line that starts at the origin and goes to coordinate 3, 4. So I start the line command, And whenever you start off something, you can always just type in the coordinates. So put in 0 and hit the tab key or hit the comma key, either one in this case. And we want 0. Press enter. And my line is now started at the origin, or at 0, 0. Now it's a little tricky. On your next point, your second point, you have to tell AutoCAD that you want to put in the exact coordinates. Otherwise, it's going to put in distances and angles. So you have to hit the pound key. That will tell AutoCAD that you mean a coordinate. So we want to put this at coordinate 3, 4. So hit 3, and you can't hit tab here. If you hit tab, then it's going to go to the angle. So you'll be drawing in a length and angle. But if you press in the comma key, it tells AutoCAD, hey, I'm drawing this, in coordinate. So we now type in the number 4, and this will put our second point at coordinate 3, 4. Press enter. So there's our line. Now we can check it. Let's select it and hover on it, and you can see the coordinate system in the bottom left that says it's at 3, 4. We did it. So you can always graph to specific points. You can draw at distances, you can draw at angles, but if you know your coordinates, you can draw accordingly. And this is how surveyors will draw in AutoCAD. They will typically need to work on some sort of coordinate system. In the United States, we use a lot of state planes coordinate systems, and that's origin is set at some arbitrary point in the real world. That's at 0, 0. And then they may go thousands of units away because they're usually covering large areas. And you can draw from point to point. So this is a very useful and just another way of drawing in AutoCAD. By default, AutoCAD sets up the UCS in a world coordinate system. That means that the origin is at coordinates 0, 0, 0, a 0 for each axis. In AutoCAD LT, there are only 2, X and Y. So it sets up the origin at those coordinates of 0, 0, and that angles facing east or to the right of your screen start at 0 degrees. So this line here is drawn at 0 degrees. This line here is drawn at 90 degrees. This line is 180. This line is 270. And then back to 360 being the same as 0. That way AutoCAD knows where everything is, and you can interact with it accordingly. Now, there are times when you need to work with a different coordinate system. An example might be of a surveyor who needs to work with a coordinate system that is offset and maybe even rotated from like a point of commencement or some other land-based marker. I've opened up the civil example-imperial file to kind of give you an idea. This road and these lots are right in the middle and aligned with our user coordinate system. But what if we needed the road and lots to match this line here of the parcel? Well, we can draw lines with it and work in it, but we have to go through extra steps. We can do that. And that's where making a customized UCS or user coordinate system comes in very handy. Now, what we want to do is to use the UCS command to create or change the current UCS. And we can save it for later use. It can help us make special views for our drawings. It can do a lot of things in it. So to get started, just type in UCS and press enter. Or you can go up to the ribbon and go to the View tab. And here you have different preset views, top, bottom, left, right. These are all for the different 3D views. You can go to the View Manager to help create or make some. Or you can go up to the ribbon. Go to the View tab, and you need the coordinate panel. Now, by default, this coordinate panel doesn't show up. And I'm not sure why it's set that way, but out of the box, that's what's happening. So we want it in here because we want to use our user coordinate system settings. Right-click anywhere in the top of this gray area on the ribbon where there's no text. Go to the Show Panels. And if there are panels in here that you don't want to use, you can easily turn them off and on. But we want to show the coordinates panel for what we're doing here. So I'm going to go to it and click it and turn it on. That will load our coordinates panel. Here we can get to all of our UCS controls. We want to get to the UCS command. And this is it right here. One thing to note is the UCS icon. It is selectable, and most of the functionality here in the coordinates panel, you can get to here just by selecting it. We'll show you that in a little bit. But if you don't see the UCS icon, come up here and go to the UCS icon button, or just type UCS icon. That will turn it off and on. If you're never going to rotate your view, if you're not going to keep track of your coordinate system, then you can turn it off so that it's not there. And there you go. But for this exercise, we want it on. So we're going to keep it on. So now if we go to the UCS command, click it, we can make changes all we want to this UCS. Now you see here in the command line, we have different options that we can use. There are several of them. And you use the option according to the information you have and according to what you want to do. So you can create a new UCS from the face of an object, from a named view, from the line work of an object. You can go to a previously used UCS. You can go to a saved view. You can go back to the world coordinates, or you can make a change according to the X, Y, or Z axis, or on the Z axis alone. The Z axes are only options available to AutoCAD and aren't available in AutoCAD LT. So if I pick Object, or I type in OB, and remember in the command line, when it gives you options to type in, the parts that are in blue, you'll be able to type in. So I can type in OB for Object. Now I need to just follow the instructions. I pick the object that I want to align my UCS to. Let's say it's this line right here. And as I put my cursor over the top, it will highlight and show you what it's going to look like. Now, you can have your X and your Y rotate on it and come from different directions. Do you want your Y to be at the top or the bottom of this view? Well, to change that, just go to the different end of the line. This is the way I want mine to show. So I'm going to pick it. Now it doesn't rotate your view. It still looks the same, but you notice the icon is different and my crosshairs have been rotated. So if I draw a line and I turn on my ortho by pressing F8, that will constrain my line work to the X and Y axis. So now I can draw lines that are parallel to either of these lines in the axis. If I draw something like a rectangle, it's right there. It follows it perfectly. Now to draw a line like this, I would have to go into several different steps into a long procedure, but I can draw it that way without switching my UCS. That's possible. But in this case, I don't have to. So to get everything back, I can go to UCS, and in this case, since my last UCS that I used was the world coordinate system, I can hit previous, or I can just hit W for world again, and that resets it. So it's very easy to do. Now let's look at another option here. UCS, I can pick the face of something, find a named view, previous view, or I can go about the X-axis or about the Y-axis. I'll turn off my ortho command. You can see me rotating it about the X-axis. Now it doesn't look like it's changed much, but that's because it rotated it about the X-axis, so it's kind of spinning around it. Now let's reset that. Type in UCS and then W for world. Now let's look at it in a much easier view. Hit Z for Z-axis. Since the Z-axis is right here at that corner and it's coming straight at me, right out of the screen, I can rotate my view this way. Now if I know what angle that I'm using, I can type it in, or I can just align it with some other object. But here's my UCS. And I can type in UCS and then W to reset everything. Now before, and you probably saw me do it earlier, type in plan and W for world. That won't rotate my UCS. That only changes my view from whatever it was to the plan view. So there are two slightly different things. When you work in 3D, UCS can be a big help. there is a dynamic UCS feature that will automatically change your UCS to match the face of an object automatically and temporarily while you're working. That's very quick, very easy to work with. It's not available in AutoCAD LT because we don't do 3D in LT. And that's getting a little bit heavy for our course here, but I just wanted to let you know that that is something that's available. Now you can create your new UCS from scratch by picking, several different points, rotating about an axis, matching an object, or using a previously used UCS. Or you can use the UCS icon itself. Here it is, we can find it and pick it. We've talked about grip edits on different things before. This has different grips for different things. So I can pick it here and just rotate the UCS icon. And now my UCS has been changed. You can pick it and rotate back. It can go from either direction. If I hover over it, I can give it different commands here as well, or I can just rotate it. If I go back to the origin part, I can move my UCS so that now this is coordinate 0, 0. I can move just the origin. I can move it and align it. Or I can reset it to the world coordinates. This is very useful, and this is one of the reasons why the coordinate panel no longer shows up by default in AutoCAD, because all of these buttons will have you do just what these few group things can do. Now you can save a UCS. Set it up however you want in any method that you want. Then go to the UCS icon and right-click. Now again, here you can get to a lot of the different UCS settings and properties. You can change your icon style to look at different ways, change the size of it, change the line width, whatever you want to do, change the colors even. And once you make your UCS, you can save it. Go to Named UCS and then Save, and then type in a name. Give it whatever name you want. Now your UCS is going to be saved over here. This is the view cube. It's another way to navigate inside your drawing. You can click over here, make a new UCS, go to one that's saved, or go back to the world coordinate system. So as I'm working, and if I want to, I can go to my UCS, create an object from here, and now I can give it another name. Right-click, named UCS, save, and I can call it whatever I want. I can call this one parcel view. So now I can quickly navigate between my different views. Just come up to the view cube and select the view you want. And you're very quickly working in your different views. That's very handy and a very useful tool. Now, another way you might want to use a UCS is if you're making an isometric drawing, or maybe a P&ID sheet where you need to work at specific angles. You can create those. You can create a UCS, let's say at 45 degrees. I select my UCS and I grip edit it, and I go to 45 degrees. I can save this view, call it 45 degrees. And now, my ortho turned on, I can draw a box that's at 45 degrees. I can switch back to my regular UCS, and I can start drawing a 3D looking box. Very easily, with very little effort. Though it's not in 3D, I've just drawn an isometric view, and it makes it easy to work in that. And I can rotate it back and forth very easily for different things. So there are a lot of ways to use or to utilize the user coordinate system to customize your working situation depending on what you need to do, and it will make drawing things easier, especially with the ortho command turned on. There are two drawing aids in AutoCAD called Grid and Snap. They often work together, but you can use them separately from each other as well. Snap is a toggle setting that is either on or off, and you turn this on or off by pressing the F9 button, or by clicking on the Snap icon in the status bar, which is found right here. Right now it's off. When I click it, the icon is highlighted blue, and the command line will tell you that your snap is on. Off, on. What the snap feature does is it restricts your mouse movements to specific increments on a grid. That grid can either be visible or invisible. Right now my grid is visible. You can set these increments to whatever value you need it to be. If you need to draw objects at incremental units or factors thereof, then snapping is a great way to go. It helps you to draw in these increments every time without doubt and without tedious data entry. The snap technique is not very useful though when you are zoomed way out or you're too far away, because the farther you're zoomed out, then the more difficult it will be to see where you're snapping to. So it's a relative thing. You'll have to pay close attention to your coordinates in this case. When you snap, you are snapping to a defined grid. That grid can be made either visible or invisible with a grid feature. It's a toggle, so you can turn it off or on by pressing the F7 key. Grid off or grid on. Or you can go to the status bar and click on the grid icon. Again, when it's on, the grid icon will be highlighted blue. A lot of times I like to work with a grid on because, well, it's a grid and it helps me to draw. It's like working with graph paper to a certain degree. With snap off, I can't select any of these lines. And as I pan around, they move. If I zoom in or zoom out, conduct a regen, meaning regen my screen. I can't do anything with them. They're just a visual aid, but that's okay. It's the same way with drawing on graph paper. They're just a visual aid. When the snap feature is turned on, it's also a visual guide, not just an aid, but it's a guide, and it will tell you where you're going to snap to, as long as you set your grid to be the same increments or units as your snap. Now, to change the snap in the grid settings, you need to open up the Drafting Settings dialog box. You can do this by right-clicking on the O snap or grid icon in the status bar. Right-click and go to the settings. There are a lot of different tabs in here to set up a lot of different things, but what we're worried about right now is the Snap and Grid tab. If you're on one of these others, or you can't see it, you have buttons over here that will scroll you through all of your different tabs. But we want the Snap and Grid tab. You can turn your grid or snap off or on right by here, and you can change the settings throughout. In the grid area of the tab, you can select the number of units each snap location will be apart. You can make the X or the horizontal distance to be the same as the Y, or you can make them different. You can set up your snap and grid increments to be the same, or you can make them different. I would tend to try to keep them the same, but you don't have to. So right now, the way our settings are in this file is that you have a snap point and a grid point at every half of a unit. And your grid is drawing a major line, these thick lines, every 5 units. Now you can change these to show where they're being displayed or where they're not in 2D model space, 3D model space, block editor, etc. You can also change it to subdivide below your grid. You can follow the dynamic UCS or not. So as you see here, as I zoom in and out, it keeps redrawing the grid with those settings. If you go back to your drafting settings window and you uncheck this box right here, the adaptive grid, it won't adapt anymore. As you zoom in and out, it stays at the size you've told it to, which is very useful from time to time. With Snap On, as you can see, my cursor automatically snaps to lines on the grid. That's very useful. That's like drawing on graph paper. So I can draw from just about any point on this grid and know that I'm drawing accurately. Note the coordinates in the bottom left of my screen. There aren't any decimals being used because we don't have our grid set up that way. It only goes to 0 or 0.5 because we have everything set to 0.5 units. So I guess some decimals are being used in this case. But what I mean is it doesn't go way out. Like now, when I'm free to move around, this is what's happening. So when you turn the grid on, you can see that a lot of times it has limits and sometimes it doesn't. You can change that by changing your limits. I changed my limits, and now I'm going to my drafting settings. You can type in OS, and that'll take you to Object Snap, but then you just go to the Snap and Grid tablet. And you can tell it to follow the limits. So if you want it to go beyond your limits, turn this on here. But now we're going to turn it off. And now it will only show the grid and our limits. What are the limits? Well, your limits, quite literally, will limit where you can draw at. There are a lot of different uses for limits, and a lot of them aren't really used as much anymore because of other tools and features that have been put into AutoCAD over the years. But you can set your limits by just typing in the word limits. And then you can manually type in your coordinates, or you can just pick a point. And you'll pick your bottom left corner, and then your top right. And this is your drawing area. This is where the grid will be displayed, and this is where you are limited to. Many users find the snap and grid features to be annoying. However, many users find them to be very useful. I would agree with both perspectives. The ability to control where your crosshairs go without having to think about it is very handy when you're first learning to use AutoCAD. Having a grid to help you visualize the length and the location of your drawing objects is also useful. Learning how big something is on the screen can take some time. Many users have a hard time adapting to that. So having a visual aid could help you in this case. Eventually, and it may take some time though, you will be able to understand how big something is on your screen. Don't worry if it takes you a while. In fact, some people never get the hang of it, but that's okay. If you have more than one object in your drawing, and trust me, you're going to, you will find that you need to navigate within your drawing. One way to get back and forth in your drawing is to use the pan command. Panning is not that difficult, not anymore. For many releases, we have had real-time panning. That means that you can see where you're panning and the screen moves along with it. There are many ways to get to the pan command. Let's open up a file. Any file is fine. We just need to have something where we can see we're moving in. Open up one you've worked with before, or just draw some objects in there very quickly. It doesn't matter. If you're not in any commands, just sitting around and panning sounds like fun, you can type in the pan command, P-A-N. Press enter. You'll get a little hand icon that comes up on your screen. Now the idea of panning is that you grab a hold of a place on your drawing and move it out of the way so that you can see something else. It's kind of like taking a piece of paper or a drawing, holding onto it somewhere, and then moving it across your table. So with the pan command started and activated, click and hold that click somewhere, and now move your mouse. Now you grab that point and you're moving it from one part of your screen to another part. Then let go. That was a pan. You didn't change any of the objects in your drawing, you're just changing your view. So the entire screen kind of moved. So that's kind of good. So now I can get from this corner to this corner. If you right click, you can exit out of the pan command. Now there are other ways to start the pan command. You can just type the letter P on the keyboard and pan. Hit escape to get out at any time. Because pan, might be too many letters for you to have to type. Or you can find it in the ribbon or find it in the shortcut menu. If you have no command activated, you can right click and hold and go to the pan command. It's right here. You can go to the navigation bar, click the pan command, and you can pan around. You can also go up to the ribbon, go to the View tab, the Navigate in 2D panel, and click on the pan command. Those are great, but nowadays, most of us, and me especially, don't even use the pan command. We just use the scroll wheel on our mouse. So if you have the scroll wheel, and if you don't, please get one. it'll be one of the most efficient-based things that you'll be able to do in AutoCAD. Click the scroll wheel and hold it. Pan around, and let go. That's so much easier. And it's transparent. We talked about transparent commands before, and pan was one of them, zoom being another one. You can use the scroll wheel for it while you're in a command. I can draw a line, pan over, and I'm still drawing my line. Quite useful. The pan command, as we said, can be a transparent command. That means you can use it while you're working with another command. Otherwise, you're restricted to using only one command at a time. But I can't draw a line and a circle at the same time, but I can pan while I'm drawing a line or drawing a circle. So if you pick the pan command from anywhere, it will automatically be a transparent command. So that means from the ribbon, from the navigation bar, from my scroll wheel. So if I draw a line, I can come over here to my nav bar, press the pan command, move around, hit escape, and then finish drawing my line. Or again, I can just pan with my scroll wheel and draw my line. Otherwise, if you draw a line, pick your first point, type in an apostrophe, and then type in pan. Press escape when you're finished, then the second point for your line. Most of the time, though, this is kind of a moot point because you're going to use your scroll wheel. What else would you do? Why would you take the time to move your mouse, your cursor, to the nav bar or to fumble through the ribbon just to find the pan command? Use the scroll wheel. But you do have options if you don't have a scroll wheel available. The zoom command is quite simple, but yet it can be very complicated. There are very many choices to choose from, but yet most of us use only two, and that's fine. The zoom command is the act of moving closer or farther away from your drawing data in order to get a different view. It doesn't change your drawing in any way, not the line work, not the information in it, just how you're looking at it. There are many ways to zoom. You can go to the ribbon and click on the View tab, then the Navigate panel. You can get to zoom this way, which are right here. The zoom button on the ribbon is in a flyout, and you have all of your different options of zooming. We'll take a look at these here very quickly. Or you can just type the word zoom, Z-O-O-M, on your command line. And then you have all of your options available to you. Now, let's take a look at each one. You have the zoom extents. This will zoom you to the maximum extents of all the objects. So if I'm zoomed in really close right here, and I come up and hit zoom extents, it zooms me all the way out so that I can see everything so that it fills up my screen. I can draw a line up here, and I can use a zoom window to zoom in to that little spot, and then come back to my zoom extents, and boom, it zooms it up. Now if I delete that object, my extents are now down here, not up there. So if I go to zoom extents, that's where it will take me. Zoom extents is a great one. It helps you to zoom all the way out so you can see everything in your file, so that now you can zoom back in to a specific spot. And a great way to zoom to a specific spot is with a zoom window. Now if I want to zoom into just this area here, I pick one point and it creates a box. Wherever this box is, that's where I'm going to zoom to. It will fill my screen with that box. And there you go. That's cool. Now another one is previous. This will just take you back to your previous zoomed state. It's a great way to go back and forth. I can do a real-time zoom. This will let you to zoom in and out in, well, real time. See, I have a magnifying glass with the plus and minus. I will click a spot and move my mouse forward or backwards, up or down. Left and right really doesn't do it. It's up and down, and will zoom me in real time. Once I let go, I can pick another spot and zoom in and out there. So that's another way. If you want to go back and forth, kind of like a sports, commentator going back and forth. He zooms in, he zooms out. He zooms in, he zooms out. You get the idea. I can zoom to all. This will zoom to all visible objects that are in my file. Again, it's very similar to zoom extents, but it's different. So let's do some stuff here to show you. This is my zoom extents. Now I can turn some of these things off. Okay, now this is all that I'm going to be able to see. Let's go back to my View tab, go to the Zoom window, and let's zoom in to this little green box. Now, Zoom Extents will take me out to the extent of my drawing. And then Zoom All is to where all of my objects are. Pretty cool. Let's undo this stuff, put everything back on. So you can see they're slightly different. And honestly, I never really use the Zoom All. The Zoom Extents I use all the time. Now, the dynamic zoom is a little different. It sort of does a zoom extents and then allows you to create a new window. So this is nice in that you can make a small window and then move it around. Pick where you want to go. Okay, so if I'm zoomed in really far, I can do two things. I can zoom extents and then zoom window to get to where I want to go. That's several steps, several commands. But if I do a zoom dynamic, it automatically zooms me out, and then I can zoom in to where I want to go. I need to slightly position my box where I want, click, and then drag to the right to make it bigger, and I move up or down to kind of change my position a little bit. This will resize your box. Find your point, click it again, and then I can move it to where I want it to go. If I want it to go right here, I can right click and it will zoom me right in. So let's do that again, a little bit more quickly and less commentary. So I can do a couple of commands in one way, and I don't have to zoom all the way out, pan across, and zoom back in. I can just zoom out and zoom in. So that's kind of cool. I can zoom by a scale factor. I can just type something in. It goes in by a factor of 10. Or if I want to scale it again, I can do a decimal. So the decimal will make things look bigger, and a whole number will make things look smaller. Now I can zoom center. Put in my magnification, and it will essentially just zoom me into that spot and center it on my screen. It's a little cumbersome, can be a little difficult. Not really useful a lot of times, but it's there. Zoom object is really cool because then you can pick an object or objects, press enter, and it zooms you right in. So this is cool if I'm, zoom extents, I'm way out and I want to go to zoom object, say that box, enter, and boom, it takes me right to it. I don't have to guess how big my window needs to be or anything. It just finds it and takes me there. And these are real-time zoom in and outs. It just zooms in a little bit, or it zooms out just a little bit. So those are nice for little presentations that you're doing. If you're presenting to a client at a big conference, you can use those. Now you can get to all of those commands if you type in the word zoom. All of those are available here. Now whichever flyout for the zoom that you used last, it will be available right here in the button, so you can just click the button and it will take you there. Now another way to zoom is with your scroll wheel on your mouse. And this is very simple. And the majority of time, this is all you're going to need. You may never come to this button at all, but you can if you want. See how much easier that was? And wherever I put my mouse or the cursor, that is the focus point for my zooming. So you just scroll your scroll wheel, roll it in, roll it out. That's very useful. And it's also a transparent command. So if I draw a line, then I can zoom in and draw the rest of my line. And if you double click your scroll wheel, that's a zoom extents. So between the zoom extents and the zoom in and out, the majority of your zooming needs are done with your scroll wheel. throw in the pan command, and I can navigate to anywhere very quickly. Now, another quick thing to do is to type in the zoom command, hit W for window, and there you go. And with a command alias of just Z, I can go ZW very quickly, or Z and E for extents. I can navigate through that very quickly as well. So the most of your zooming and panning needs, your navigating needs in AutoCAD will be done with your scroll wheel. Or you do have available a plethora of zoom type options that you can use. To finish up this chapter, let's review what we've talked about with a little project. We'll just go over a few simple steps that will allow us to practice some of the concepts in this chapter. Most chapters in this video will have a similar project at the end. Let's begin. To start off, let's make a brand new file. You may be in a new file already, but we're going to start off with a brand new file so that we get familiar with the process and all the steps involved in it. There are several ways, as we talked about, to start a new file. You can just type in new, but let's go through a lot of the steps. To get you used to working with the ribbon, go up to the application menu, which is that big red A in the top left corner. Click New, Drawing. This opens up the template folder. We want to use the template file called acad.dwt. Click Open, and here we go. We want to create an architectural drawing using feet and inches for our units. So we need to click on the application menu again to check our units. Go down to Drawing Utilities, and then Units. Okay, we need to set this up. It's already in inches, and it should be for you. If not, click on the arrow and select inches. Now we want to go to Architectural. So you go to the length type, Architectural. Precision of 1/16 of an inch is fine for this project. As for the angles, let's make them decimal degrees and a precision with 1 decimal place. For what we're going to do, this will be satisfactory. And click OK. Now, it's always good practice to save your file early on and then very regularly after that. There's always a chance that something will happen and you'll lose your work. AutoCAD crashes, especially once you get into a very complicated file. And then when you start adding references to other CAD files or to other data sets, etc., then it just bogs it down. And if your hardware isn't up to snuff, then you could have troubles. And if your hardware is absolutely top of the line, it could still be a problem. So it's just a common thing that happens with AutoCAD. It's not your fault, it just happens. So you have to be prepared for it. So let's save the file. You can save it anywhere that you'd like to, but make sure it's in a place where you know where to go. I suggest making a folder for all of your CAD work here, somewhere on your computer, on an external hard drive, a jump drive, something. You could even save your work in Autodesk 360, which is Autodesk's cloud-based support platform. There you'll be able to save files to the cloud, and you can access them from anywhere. You can even access them from your mobile device. If your hard drive crashes, if your computer explodes and bursts into flames, you'll still have your files available to you on the cloud. AutoCAD 2013 and AutoCAD LT 2013 have a lot of integration built into it with the cloud. So let's save the file. Click on the application menu, and you can click Save because we started with a template file, so it's not saved already. Browse to a place where you want to save it and save it. You have some options here that you can set up your automatic online saving properties. Just click on it. It will open up your information, give you some information and data on how much cloud space you've used. I've only used 5.7 megabytes of the 3 gigabytes that are provided free to every customer. But you can enable the cloud storage. You can even sync your settings in AutoCAD. And you can set it to automatically save every file you work on. Now, if you're working with a lot of files that are very large and have a lot of memory, you could fill up that 3 gigabytes. So be careful. For now, you may want to keep it on, but it's up to you. And to get to Autodesk 360, you can click on the button here. When you're done, Click OK, and that will save your settings. If you want to save it to Autodesk 360, you can just click right here. That will open up a folder that you have automatically saved up in your hard drive that automatically syncs with the cloud. Save your files here if you'd like. We're going to name this file Chapter Project. This is Chapter 4, so we'll call it Chapter 4 Project. You can call it whatever you'd like. Then click Save. Now, since this file has been synced to the cloud, every time you save it, your cloud file will be updated. You can go to the Online tab right here on the ribbon to sync your files, to look at your files that you have, to upload them, to download them, etc. All right, that was a little extra I threw in there. But let's get back to where we're at on our chapter project. So now that we've set up our file, set the units, and we've saved it, keep in mind that it's a good practice to save your file regularly. So save early and save often. There's always a chance that something will happen and you'll lose your work, and that's bad. So let's draw something. I know we haven't talked a lot about drawing something, but that's coming. Now we've built a foundation on how to interact with AutoCAD, and we understand the interface now, and we know where things are. And so if we need to find something, we can. So let's take a look here. Let's draw a rectangle. Now to do that, you can just come up to the Home tab on the ribbon and the Draw panel and click Rectangle. Now, we just want to draw something here so that we have an object to work with. So you can pick anywhere on your screen. Pick your first point with the left click of the mouse, move it up to the top right, just anywhere. It can be small, it can be large, it won't matter. And click again. And there you go. You drew a rectangle. Good job. Now, we're going to do something else. Let's work with the grid. By default, in that acad.dwt file, the grid is on, or at least should be. If it's not, that's fine, but we want to turn it on. So if it isn't, you can come down here to your status bar and toggle it off or on by clicking it. Or you can press the F7 key. Now we also want to turn on our snap functionality, but let's set some of this stuff up first. Come down to your status bar, right click, and go to Settings. This will get you to your settings here. There are a lot of different things you can mess with. Bowler tracking, object snap, 3D object snap, but not in AutoCAD LT, or your snap and grid. This is what we want to do. So let's turn it on. Right now it's set to space everything at 1/2 inch. Because we're using architectural units of inches, 1 unit is 1 inch long. So keep that in mind when we're drawing. Now let's tell it to make a grid line every 10 units. So let's change this to 10, because that's what we're going to snap to. And we want it to be equal X and Y spacing. So keep that locked in. And now come down here for the grid, type in 10 units. Okay. Now you can see here our grid is quite large, but that's okay. Make sure your snap mode is turned on, and let's do some work. So pick the rectangle. You can use a crossing window, you can use an inclusion window, you can use the fence, or you can just select it. Because it's a little small, we want to get rid of it. Once you've selected it, you can use the Erase command, which is right here on the ribbon, in the Modify panel. Or, once you've selected something, you can press the Delete key, and that's the same as erasing. So that's a real quick tip if you want to get rid of something. Select it, and then hit the Delete key. It's very quick, very efficient. Now let's double-click on the scroll wheel. This will do a zoom extents. See, we don't have anything here, so that's okay. So now with your snap mode on, let's start to draw something. Let's use your scroll wheel to zoom in or zoom out, pan around a little bit. And one thing you might find that happens in AutoCAD is once you zoom out so far, it won't let you zoom anymore. This is an old setting that's in AutoCAD that's been around for a long time. And it just sort of says, I can't go any farther. So what you need to do is execute what's called a regen all. And that is just typing in REA. That will refresh the screen, refresh the drawing area, tell AutoCAD to, hey, reset. doesn't delete anything, it doesn't change anything. It just sort of clears out the memory and clears out a little bit of stuff on your screen, smooths out arcs and circles, and allows you to zoom out again. See, even your pan will get stuck, just like this. This is going to happen to you all the time. So just remember REA. And there you go. It gets real annoying from time to time, but once you know what to do, it's a quick fix to get through it. Now let's start drawing a line. Let's type line on the command line. Press enter. Let's draw a triangle. Now remember that we're snapping to specific places on the grid. That can help us line up our lines very easily. So pick a point, snap, snap again, and then just snap to the end. There's a triangle. See how easily the snap function allowed us to work? If we draw the line again, I can come to this point and draw in some more triangles. I can keep drawing until I finish off the command. And there you go. It's very easy to draw things with Snap-on. It's very quick, and it's very simple. So if you're an architect and you're laying out a room, you can set up your grid work so that it's to a certain unit. And that unit could be, the width of your wall. It could be, 1 foot, 1 meter. And you can very quickly draw some shapes. Okay, I snapped to the wrong spot here, so let's undo that. Go up to your quick access toolbar and click the undo arrow. Well, it undid my whole inside box. Yes, because we did all of that in one command, in one function. So we need to draw that back. Draw a line, start the line command again. And let's draw. We'll keep the width of this box on the inside of the other box to just 1 grid space wide. When you're done, press enter. Okay, so we've drawn some things that we've snapped to. Now let's zoom out and let's draw some lines, making another box to exact coordinates. So start the line command again. And let's tell Autocad to go to specific coordinates. Let's go to coordinate 10, 60. Press enter. Now remember, these units are in inches. So coordinate of 10, which brings us right to this snap point anyway, is at 10 inches along the x-axis. And then a coordinate of 60 will bring us up 60 inches on the y-axis. So that's great. So if we want to draw a line now that is 50 units long, well, we can snap to 5 different places here on the grid because we have set up our grid to be 10 units long, or we can just do the math on the coordinates. Since we're at x coordinate of 10, we need to go to x coordinate of 60. That will put us at 50 units wide. So to tell Autocad that, hey, we want to draw to coordinates again, you need to first start with the pound key and then type in our first unit, which is going to be 50, and then comma, and we'll draw it at 60. This will put us at a horizontal line to the right, 50 units long. Press enter. And there's our line. Drawing to coordinates can be difficult and tedious because you have to know exactly where you need to put it. And typically that won't be the case. There are exceptions, of course. Surveyors all the time will draw to coordinates because they know where the coordinates are for the points, and if they're getting property corners or something like that. So that will happen. We can also draw a line in a direction at a specific length. So if we draw a line, we'll snap to right here. And let's say we want it to be 50 units long, and press the tab key. And as you can see, this line is now 50 units long in any angle direction that we want to go to. And click the button, and there you go. Very simple, very easy to do. So there are a lot of ways to work within AutoCAD. Let me show you another little trick here. Let's draw a line again. Pick a point. Type in the @ symbol. This will tell AutoCAD to go to a specific length and then angle. So type in 3, tab, then hit the less than sign, and then 90. Press enter.